Okay, this might be the most kind of complicated ones among all these 10 questions in here. But let's look at the situation. We have a reversed conical tank. So it should look like this way. And the height of that is 10. And the original radius of that top must be 4. And the water is pouring into that tank. And the rate of that volume, right, is going to be 10. Okay? So we are looking for some information about that water volume or level, right? So at certain time, the water must be filled this much, right? Okay, let's say that. Then, first of all, we need the volume, right, of that water. Or this water tank, but water tank is fixed, but the volume is changing of the water. So that one regarding the radius of that top, the circle portion, and the heights at the time. Okay? So it's going to be 1/3 pi r squared times h, right? There. Okay, then from this, one information we know is what is the rate of change of the volume of that, the water, that is 10. Because it's pouring down into there, so the volume is increasing, so it must be positive 10. Okay, then they're asking how fast the water level is changing. So they're asking what is dH dt is, right? When the H becomes 5 feet. Okay? So they never mention anything what R is, right? So we have to figure out the R to calculate the whole thing. But before doing that, let's just calculate it, okay? to get the derivative. So when you take the derivative, we know it's 1/3 pi, and this is a product. Okay? So it must be 2r dr dt times h plus, that's f prime and g part, and f times g prime part from the product rule, right? Like this. So that is 10. Okay, that is pi over 3 and 2r, and we don't know dr dt, but the h is 5 because of that. And once again, we don't know what r is, and dh dt is what we are looking for. Okay? So all we need is what is going to be r at that specific time, and what is dr dt at that time, right? Then look at the situation when h is 5. Then we can calculate the radius at that time, because the ratio between the heights and the radius from in this tank is 10:4, right? So in this triangle, we can think like this. It's 10, then 4, then water has 5, okay, for the heights. Then the R at the moment is, the ratio is changing 10:5, so 4 must changing 4 to, the radius must change from 4 to 2, right? So from there, we know at that time, right, when height is 5, the radius must be 2. Okay, then what is dr dt? Okay, at that moment, how much is changing? And R is how much is changing according to that change. And that relation, the value for dr dt, came from different formulas. Okay, so look at here. In this triangle, we have this big triangle, fixed one, and the ratio is 4 to 10. And no matter what the heights are, the radius regarding to that is r to h, right? So the ratio between r and h must be 4/10 equals r over h, which means 4/10 times h is r, or 2/5 h equals r. That's the relation between these two. So from there, if we take the derivative again, dr dt is 2/5 dh dt. What does that mean is we already know what R is at the time, right? So we can change that one to 2 and 4. So the only unknown at this moment is dH dt, which we are looking for, and dr dt. Then it's a little bit difficult to find dr dt from that expression. So we just look at different point of view, and that's the relation between dr dt and dH dt. So instead of dr dt, we can substitute 2/5 of dH dt. Okay, that's how we remove dr dt, and everything is about dH dt. That's the only unknown in this expression, right? So just rearrange it, and you can find what dH dt is.